All right, welcome to the session. Now in this video, we're going to start a new topic, grade 10, trigonometry. So now, this is the basic background that you need for grade 10 trigonometry. Now here we have a presentation of a right-angled triangle. Why do you call this type of a triangle right-angled triangle? Because there's 90 degrees in it. Now we know that the sum of angles in a triangle, they're actually equals to 180 degrees. So when we do the trigonometry, we're going to use these types of triangle here in grade 10. Now, in order for us to calculate the sides of a right angle triangle, I believe we are actually all familiar with this term, the theorem of Pythagoras, or the Pythagoras rule. So when you are given a right angle triangle like this, we have three different sides. But the side that is opposite to 90 degrees, which is this side, we call it the hypotenuse. The hypotenuse, in this case, it is denoted by letter R. Now, when you have a look at this side and this side, here we have Y, which is from there to there. And then here we have X, which is from there to there. Now, these two sides, they are actually adjacent to 90 degrees. Now, using theorem of Pythagoras, we know that y squared plus x squared will yield to r squared. That's what we know. Now, because now we want to combine this right angle triangle with what we call the trigonometric ratios. Now, the trig functions or the trig ratios that we use are sine function, cosine function, tangent, which is tan function. Okay? So now, when we use these trigonometric ratios, like I said, we use them in relation to this type of a triangle, which is called the right-angled triangle. Now we know that when you want to determine the sides, like I said, we use the rule of Pythagoras, depending on which sides are provided. Now let's talk about the trigonometric ratios in this type of a triangle. Like I said, this is two different presentations. Here, the side it is written in full to show you that, let me call this triangle A, B, C. This is the same triangle, which is triangle A, B, and C. Now, having a look at triangle ABC, let's talk about side AC. What is the name of side AC? It is called the hypotenuse side. Why? Because it is opposite to 90 degrees. So, like I said, when you have a look at this triangle, which is the exact same thing as this triangle, here we have letter R, which is side AC, meaning AC is equals to R. So R also denotes a word hypotenuse. Now let's talk about side AB. Side AB, we're gonna call it an opposite side in this case, which is side Y. But the question is, why do we call this side AB, the opposite side? We call it the opposite side because it is opposite to the angle provided in this diagram. So side AB in this case, or in this triangle, we're going to call it the opposite side, which is Y side in this triangle. And therefore, side BC, we're going to call it the adjacent side in this case, which is the X side on this triangle. We're going to call it the adjacent side. Now, the question is, why do we call, again, this side the adjacent side? We call it the adjacent side because it is adjacent to the angle of interest or to the angle provided in this diagram over here, which is angle phi. We call this phi. So this is what is happening. You need to know that the side that we call the opposite side, it can be adjacent, but I'll tell you how. Now let's modify the very same triangle and give ourselves angle in a triangle. Let's call this triangle over here triangle theta. Okay, let's call this angle over here angle theta. Now, look at angle theta. Angle theta, it is opposite to which side? It is opposite to side x in this case. Remember, we said side x, it is adjacent. But it is adjacent to this angle. Yes, side x, it is adjacent to this angle over there. But side x, it is opposite to theta. So if we want to talk about angle theta, therefore side x, it is the opposite side. Then what about side y? Side y is going to be adjacent side to angle theta in this case. So you see in this diagram, we said side y, it is opposite side. Yes, side y, it is opposite, but to which angle? To angle phi, which is this angle over here. But to angle theta, side y is going to be the adjacent. Remember what is adjacent? Adjacent, it is something close or next to. That's why we call it the adjacent side, because it's close to angle of interest in this case. And therefore, hypotenuse will never change, because hypotenuse, it is the side that is only opposite to 90 degrees always and all the times. So meaning x and y can change to be opposite or adjacent depending on a angle provided. So like I said, there are three trig ratios that we are actually going to learn, okay? So we have the sine ratio, we have the cos ratio, and then we have the tan ratio. So when you talk about the sine ratio, let's refer to the diagram again. Let me erase all of this so that you don't get confused. Now, if we want to use angle phi in this case, let's go back to the diagram. When you use the sine function, you're going to say sine phi is equals to opposite over hypotenuse. Remember, sine phi is going to be opposite over hypotenuse. Opposite side, which is this at the top, hypotenuse side, which is this at the bottom. And then when we use this diagram, we're going to say, what is sine phi? Sine phi is going to be opposite over hypotenuse. So that means our opposite will denote it as O over H, which is our hypotenuse. Oh, here we use this triangle, okay, Y over R. So we can say Y over R. That will be our sine function. And then when you use the cos function, we want to determine cos phi. So now how are we actually going to determine cos phi? So now this is how we determine cos phi. We're going to say cos phi, it is adjacent over hypotenuse. We look at the phi and we look at the adjacent side. The adjacent side, it is this side over here. We're going to say adjacent over the hypotenuse. That will be the cos phi, which is A over H. Having a look at this triangle over here, what is cos phi? It's going to be adjacent is the x side. X side, which is BC, it is adjacent to angle phi. And then the hypotenuse would always be R, which is opposite to 90 degrees. And then lastly, let's have a look at the tan function. So tan phi in this case is going to be opposite over adjacent. So where is opposite? Again, there is opposite of phi, opposite over adjacent, which is this side over here. But when we use this triangle, we're going to say it's going to be opposite, which is y, over adjacent, which is x over there. Now, here's the thing. A lot of learners, they forget these things, right? They forget what is sine function equals to. Is sine function equals to opposite over hypotenuse or adjacent over hypotenuse? Sometimes you get confused, right? But the simplest trick to always remember this, since you're in grade 10 till grade 12, you're going to use this simple trick, which is called SOHCAHTOA. Okay, it's called SOHCAHTOA. Okay, it's called SOHCAHTOA. So SOHCAHTOA, it's actually a trick that everyone uses to determine the trig functions with their sides of a triangle. So have a look at S. S stands for sine, and then O is going to be opposite over hypotenuse, which is this one, opposite over hypotenuse. Can you see that? Now let's talk about cos. Cos is going to be adjacent over hypotenuse, meaning it's going to be adjacent over hypotenuse. You see that? Now let's use tan. Tan, whatever, tan theta, tan alpha, tan phi, tan omega, tan whatever, meaning we're going to use opposite over adjacent, which is opposite over adjacent. So when you forget all of this, you can always refer to SOHCAHTOA. I don't think this term you can forget it because it's a term that you need, especially when you practice more often. You will quite be familiar with this term, which is called SOHCAHTOA. Okay, so this is what we use to actually relate the trigonometric ratios with their sides. Now, here we have an explanation of trigonometric ratio, angle, and the sides. So that means here, what does sine phi represent? It represents which ratio you are working with. So which ratio are we working with here? We are working with sine ratio. But if we had cos theta or cos phi, it does not matter the name of the angle. So these are the Greek symbols that are used for different angles. Phi can be 60 degrees, can be 20 degrees, can be any magnitude of angle, okay? So now when you talk about cos phi, okay, let me denote the very same Greek symbol. When we want to determine cos phi, right? Cos phi in this case, it's a ratio, okay? Tan phi in this case, it is also a ratio. So it shows which ratio are we working with. And therefore phi represent the angle, like I said, okay? So this thing over here is angle phi, or you can call it, if you have theta, any angle, or beta, or alpha, or omega, we can call it any angle, okay? So this represent the angle. And then O over H, it represents the sides the ratio is equal to. That's why I say to you, we use this thing to relate the ratio with the sides of the triangle. Now, we're going to have to go through the questions and apply the basic that we have just learned. Now, the statement reads as follows. It says to us, write down the ratio of each of the following in terms of ED, DF, and EF. So we're going to answer these questions 2.1.1 up until 2.1.6 using this triangle over here. So what is the name of triangle? It is called triangle EDF. And then what is given in this triangle? We are given angle alpha, and we are also given angle phi, and we have 90 degrees. So that means this is a right angle triangle. So we need to write the ratio, which is this, right? Of each of the following in terms of ED, DF, and EF. Now, in order for us to answer this question, so that means we have angle alpha, and then we have angle phi over there, EFDE. Let's determine sine alpha. So let's try to answer question number 2.1.1. So we want to determine sine phi, right? Sine phi, which is this angle over there. Remember, what did I say to you? I said if you forget all of this, you use your term SOHCAHTOA, right? Because sometimes you don't know what are you going to write. Maybe you get confused whether you write opposite over hypotenuse or you write adjacent over hypotenuse. So the simplest trick to use, like I said, you use what we call the SOHCAHTOA, okay? You use SOHCAHTOA. Let me write it over here. We have what you call SOHCAHTOA. You write it somewhere on top of your page, right? This is what we're going to use. Now, because we are dealing with this function, which is sine phi, we're going to say sine, it is actually opposite over hypotenuse. So that means if we want to talk about sine phi, we need at the top opposite side, and then we need the hypotenuse side at the bottom. So you go to a triangle because the angle of interest, it is phi. You go to triangle and look for angle phi. There is angle phi. Now let's talk about the opposite side to angle phi. The opposite side to angle phi, it's going to be ED, which is this side of a triangle from there to there. This is the opposite side to angle phi. And then what is the hypotenuse side to angle phi? I said to you, hypotenuse will always be opposite to 90 degrees. So that means this will be the hypotenuse side. Now let us write sine phi, then using sides of this triangle. So side phi is going to be opposite. Opposite, it is ED, right? It's going to be opposite ED over hypotenuse. Hypotenuse in this case, we said it's opposite to 90 degrees. It's going to be what? It's going to be DF. And then we are done. Because literally, the statement said to us, write down the ratio of each of the following in terms of ED, DF, and EF. So this is the first answer to this ratio of 2.1.1. Now let's move to 2.1.2, which is cos phi. Now, what is the ratio of cos phi? Say maybe it's an exam you forget, right? Your soccer tour will always be helpful for you. Now, we know that C is for cos, and we know that cos, it is actually adjacent over hypotenuse, right? And then you go to your diagram, right? You go to your diagram. Let me erase this once. You go to your diagram. You're gonna, because you are dealing with cos phi, you look for angle phi in your diagram once more again. And you know that because this phi, it goes with cos. And we know from our soccer tour, we know that cos, it goes with adjacent over hypotenuse. So let's go and look for a side that is adjacent. Cos adjacent. So remember, adjacent is something that is close next to. Even DF, it is adjacent, but we have already indicated that DF, it is hypotenuse because it's opposite to 90 degrees. So that means EF will be the adjacent side to this angle, which is angle phi. So that means using cos phi ratio, it's going to be adjacent over hypotenuse. So our adjacent is going to be EF over hypotenuse. Hypotenuse, remember, it's always opposite to 90 degrees, which is DF. And then we are done answering 2.1.2. Then we go to 2.1.3. Says determine tan phi. Look at me now doing theta. Determine tan phi. Now, to determine tan phi, again, it's advisable to use SOHCAHTOA, TOA, T for tan. So what is tan? Tan, it is actually opposite over adjacent, right? Tan will be opposite over the adjacent. So again, we go back to our diagram. We go to angle phi because we are talking about angle phi. There is angle phi. So which side? It's opposite and adjacent to this angle, angle phi. The opposite side, again, is going to be ED because it's facing angle phi. They are opposite to one another. It's facing it. So it's the opposite side. And then the adjacent side, it is the one that is next to it, which is ED. I mean, sorry, EF. Okay, ED, it is the opposite side. EF will be adjacent to this angle over there. So that means we're going to write opposite over adjacent. So what is opposite? Opposite is going to be side ED over adjacent. Adjacent is going to be side EF. And then we are done with this one. And then we jump to 2.1.4. Now 2.1.4, we have sine alpha. Now we're going to work with sine alpha, not phi anymore. Again, we'll repeat the same process over and over again. Now, to determine sine alpha, Sine, it's opposite over hypotenuse. But because we are talking about sine alpha, you go to your diagram, gonna look for angle alpha. Where is angle alpha? There is angle alpha over there. Now, which side is actually, because we're using sine function, so which side is opposite to angle alpha? Which side it is hypotenuse to angle alpha? So angle alpha, it is opposite to which side of a triangle? EF, this side. It's facing it. They are directly facing each other. This angle and this side is opposite in front of it. So that means EF will be our opposite, and hypotenuse doesn't change because it is always opposite to 90 degrees. And therefore our DF will be our hypotenuse. So that means sine alpha is going to be EF all over DF. Then we move to question number 2.1.5. We have cos alpha, which is equals to, again, go back to your SOHCAHTOA, right? Utilize your SOHCAHTOA to determine the sides. Now, using SOHCAHTOA for cos alpha, again, we are talking about alpha. So you go to your SOHCAHTOA, remember cos is adjacent over hypotenuse, and you go to a diagram, look for angle alpha again, using cos, it's gonna be adjacent. Adjacent is the side next to it. This is hypotenuse, right? Let me just write arc so that we don't forget. And remember, hypotenuse is also an adjacent side. But because it's opposite to 90 degrees, it's hypotenuse. So we can't call it the adjacent side because, like I said, adjacent is something close to. If someone is adjacent to you, is next to you, right? So that means this angle, this side, it's hypotenuse, which is R. So meaning our adjacent will be ED, which is this side over here, which is not even opposite to 90 degrees. It's just as adjacent to angle alpha. So that means cos alpha will be adjacent over hypotenuse. Our adjacent is going to be ED. And then our hypotenuse, which is R, is going to be DF. And then the last question, 2.1.6, we are looking for tan alpha. Now again, SOHCAHTOA, opposite over adjacent, right? TOA, T for tan, opposite over adjacent. Which angle are we talking about? Alpha. You go to your diagram, gonna look for angle alpha. So that means tan alpha is gonna be, to alpha is gonna be opposite, it's gonna be EF. And then the adjacent is gonna be ED. So that means here you're gonna have EF over ED. And that's it. That's how we solve these questions over here. Okay. All right then. So now we jump to example number 2.2. Now, number 2.2, we are just given the diagram. We have 3 triangles. The first triangle is going to be triangle ABC, the big triangle. And inside of this triangle, we have 2 triangles, which is ABE and triangle BEC. I hope we can all see these triangles, right? Now the statement says to us, write down the following in terms of AB, BC, AC, BE, EF, and CE. All of these sides are sides of these triangles that we see over there. Okay. So now the first question says to us, 2.1, sine A of ABE. Okay. I'm not gonna do all of these questions. You can do the remaining questions for your practice. Just gonna do a few of them. Okay. So now the questions that I choose to do are these ones over here. Right. So now let's start with question number 2.1.1, right? So, sorry about that. 2.2.1 says to us, write the ratio of this one. Sine A of triangle ABE. Sine A of triangle AB. Firstly, let us go look for triangle ABE. Triangle ABE. It is this triangle over there. Now, because now we know the triangle, let us write sine A of that triangle. So sine A of that triangle, here we have I, sine A of that triangle, remember, what did I say to you? Always, same basic over and over again. You're going to use your what? Your SOHCAHTOA, right? So, let me write it here. SOHCAHTOA, all the times. Make life much more easier. Right. So now, what is sine A of this triangle? So A is this angle over here, okay? This is angle A. Call this angle A, which is at this vertex, okay? So sine A is gonna be, remember when you use sine, we use opposite over hypotenuse. So now sine A, we have opposite, this side is opposite to it, right? Which is side BE. So we have opposite, which is BE, over hypotenuse. Where is hypotenuse? Hypotenuse, remember, is a side that is always opposite to 90 degrees. So meaning AB for this triangle, AB is opposite to 90 degrees, right? So that means this will be our hypotenuse, okay? That will be our hypotenuse. So that means our hypotenuse is going to be AB. And then we are done. Now we move to 2.2.2. We want cos B of which triangle? Triangle BEC. Once more again, we go back to our diagram. Look for triangle BEC. Now, triangle BEC, we have B there, we have E there, then we have C there. So that means we are talking about this triangle over here, right? BEC. So, angle E1, okay, angle E1 is also equals to 90 degrees because here we have sum of angles in this triangle. So before we calculate this angle, it is always advisable to determine the angle first so that we know that in this triangle we have 90 degrees, okay? At first, we were not given, or we were not actually told that E1 is 90 degrees. So that means the first thing that we're gonna have to do is to do what? Let me write E there. The first thing that we're gonna do is to do what? Is to determine the what? That this angle over here is 90 degrees because we don't see 90 degrees. So we can't just say we have hypotenuse. Where's the hypotenuse? Do we see 90 degrees here? No. So let's firstly determine 90 degrees, okay? So before we solve this question, cos B, let's prove that that is 90 degrees first. It's always advisable, okay? So we're gonna say angle E1 in this case is gonna be equals to 90 degrees. Why? Because it's sum of angles on a straight line. We know that sum of angles on a straight line, they add up to 180 degrees. So this is 90 degrees plus E1 is going to give you E1, and then we equate to 180 degrees, okay? You don't need to do it step by step, but it's fine. Let me do it step by step for you so that you don't get confused. So we're going to say angle E1 plus this 90 degrees is equals to 180 degrees, right? 180 degrees. And therefore, what's the reason for that? We're going to say angles on a straight line. And therefore, we can now say angle E1, when we take this 90 over there, you're going to have 180 degrees, subtract 90 degrees. And therefore, angle E1 will now be equals to 90 degrees. We have proven that angle E1 is equals to 90 degrees. Therefore, look at triangle BEC, the very same triangle that we are interested into. It has 90 degrees in it. Now we can freely talk about the hypotenuse, which is going to be side BC, which is opposite to 90 degrees, right? Now let us determine cos B. Now, in order for us to determine cos B, we're going to say cos B of triangle BEC is going to be equals to how much? Remember, cos from SOHCAHTOA is going to be adjacent over hypotenuse. So that means, because now we're talking about because B, where is B? This is the angle B we are talking about here, is B of this triangle. BEC is angle B. So which side it is adjacent to angle B? It's BC, which is, no. Yes, it is adjacent, but be careful. This is hypotenuse, right? So the adjacent side is going to be BE, not BC. It's going to be BE. So that means we're going to have BE all over, because it's adjacent over hypotenuse. Hypotenuse is going to be BC. Okay, that will be 2.2.1. Sorry, 2.2.2. Now we move to 2.2.3. 2.2.3 says tan C. We determine tan C. Now let's have a look at tan C. So in which triangle? The very same triangle, which is BEC. The very same triangle, which is BEC. Let me erase this ones, previous ones, so that we don't get confused. Now the very same triangle, which is BEC, we're gonna look for tan C, right? Where is C? Where is angle C? There is angle C. But what is tan? Tan, remember, it is opposite over the adjacent. So we're gonna look for opposite and the adjacent side to angle C. Which is the opposite side? This is the facing side to this angle, which is BE. So meaning tan C is gonna be BE, which is opposite over adjacent, right? Which is EC is adjacent. Remember, R is hypotenuse, okay? Don't confuse that because it's opposite to 90 degrees. So that means it's going to be BE over EC, which is the adjacent side. Then we are done. And then the last question, 2.2.4, says to us cos C, again, of the very same triangle, which is BEC. Cos C, we still go to angle C, which is this angle over here. Remember, cos, it is adjacent over hypotenuse from SOHCAHTOA, right? So which side is adjacent to angle C? Which side is adjacent to angle C? It's going to be EC from this triangle, BEC. It's going to be EC over, remember, cos, right? Adjacent over hypotenuse. Hypotenuse is always opposite to 90 degrees, meaning our hypotenuse in this case is going to be side BC. It's going to be BC. And therefore, that's how we solve this. And make sure that you take these other remaining questions as your examples, and then you solve them by yourselves. Okay?